Hello, my name is Ildiko,
And I'm Phil.
and this is the My Open Source Experience podcast, where we discuss all the things about the mechanics of open source in business and in communities. Follow the podcast on your favorite platform and check out the latest episode on Season 3. In the first segment, Austen Bryan talks about how the US government's supply chain has been changing and how that evolved the business language around it.
Particularly with the government source of your interest in this space. I find it really interesting, when you're looking at partners and when you're looking at open source and partners, you can do things and have a partner do something for you. You can drive something in an open source community and have that partner pick it up and sell it to you and support it for you, but it was a feature that you wanted. So the spectrum of things that can be done with regard to partnership and your ability to drive the things that you want to drive with that partner or your vendor, or in some sense, when you have customers, and if you think of Defense Unicorn, there's this three-way relationship that exists where normally it's just, vendor customer and you're working something out. There's this now thing that's a community that gives you another entry point to have conversations, gain allies, to do dual use as an example, because dual use, open source projects are looking for dual use in a sense, right? Because the broader the community, the more people are doing things to scratch their own itch that ultimately serve the core as well, the better everybody is, right? And so that's, in some sense, that's also dual use. So can you talk about your learnings about, how did that manifest for you? How did you start to figure these things out, and how did you use that, right, as yet another lever to be able to have these relationships where the community was part of them? Somewhat of a complex question, I know, but give me your thoughts there.
Yeah, I'll start by saying I didn't realize when I was a government program manager how much I was viewed as like a cash register walking around on vendor floors. I got a lot more attention then than I do now, which is a good thing to me. But I bring that up because the government is a unique space. They have career fields dedicated to what they call acquisitions, which are people who acquire things on behalf of the government, contracting program managers and engineers in particular. And I bring that up because I went through 11 years of on and off training from the government on how to acquire things for them. And there's this thing called the Federal Acquisition Regulation, the FAR. It's, I think, 1,800 pages of legal documents on how to effectively contract, like what are the rules? Because we are basically giving government taxpayer dollar, right? Like all the money the government spends has been cycled through from our own income tax and whatever else. And so I bring that up because the government has no idea how to buy open source. I would say the average person doesn't know how to buy open source. And so this topic comes up and you're like, there's nothing in the rule book that I've learned that ever speaks to this directly. So now you're like trying to translate, federal regulation interpretation to vendors who have never worked with the government. And you're like, you feel like you're speaking Chinese and English to each other, even though you're in theory speaking the same language. And I would say the other part I'll add to that is like the government, I don't want to simplify it too much, but I feel like they need to do one thing, and that's like award really big contracts to traditional primes. And I'm not ever trying to say that's a bad thing, because there's a reason that it has fallen to that, and that works in a lot of cases because it does. But what I would say is the prime contractors, and if for people not familiar with that term, that's the Lockheeds, the Northrops, the Boeings, the General Atomics, and I'm going to miss some. And if people watch this that work at those companies are going to be offended I left them out, and I don't mean to do that. But there's a handful of companies who are massive who do this, like that is their business. They and the government know how to work together, but those companies came along in what I'll call like the manufacturing era, right? Like they learned how to do business with the government and how they like to do business in a way where I like to say they bend metal for a living, right? At the end of the day, they know how to like create manufacturing lines to build a jet, to build a submarine, to build a satellite. And that's a very, very, very hard job to do. But there's some systems being built now that don't have any of that, right? They still need an integrator to a large degree, but they're integrating different supply chains of purely software, sometimes running in a cloud that you can't see, right? Like you can't walk out to the assembly line and check how things are coming off, like physically, like people got used to that, right? And so I only bring that up again, not to say one is better, good or bad. They're just different models. And unfortunately, the defense space, in my opinion, at the time when I was in, was still just teaching you how to like work with people who are building assembly lines and building integration that way. And I think what we were in the throes of change, in the time that I was in, was like, how do we shift this model, this giant system that is the Department of Defense, to understanding like, hey, if I'm building a command and control center, it's a bunch of signal input into a massive data center, interpreting that data, making a decision, shipping information back out. Nobody's building a jet, right? We're not doing that. I mean, there's a lot of people who build servers, a lot of people who build software. And now all of a sudden it's like, it's a completely different paradigm on who you work with and how you contract. And I think that was the hard part is finding contracting officers who are allowed to sign contracts with partners and convincing them that like there's a different way that we should partner. Because as I've learned now at Defense Unicorns, we have some venture backing now. And I only bring that up because in that conversation, we had to translate government sales and contracts to people who are expected to see enterprise SaaS type returns, multiples, reporting. And honestly, as I looked back on it when I was in government, it was kind of the same conversation, but in reverse. I was talking to companies who wanted to see specific annual recurring revenue license support structure on their end to convince their people that they should take the deal, even right to work with the government. And I had to convince the government on the other side that, hey, this contract structure that looks different is okay. Like it's safe. Here's what we're going to do. Here's how we're going to measure value. Here's how we structure milestones and deliveries. Here's how we evaluate earned value, right? There's the worlds don't speak to each other. And going back to this concept of understanding business, like if you can't make that translation, there is no dual investment because both parties, not for better or worse, just can't talk to each other. They don't understand each other's incentives.
In this segment, Samson Goddy shares why and how to use business language to talk about open source within your company. Someone who wants to be able to work on open source as part of their paid job, they need to learn corporate and business language to talk about open source.
Unfortunately, you need to see it less of a project and see it more of a product. Companies like to hear product. They don't like to hear project. Project feels very weird to them. They want to see product because with products, they can justify a lot of things. It's one of the things I learned over the years. But yeah, it's weird. And I think the same thing goes, right? Because even in open source, we've used the term project a lot. And companies are now like, okay, why exactly are we giving money to the Django community? Or whatever community. And then you realize that, oh, okay, this is what you depend on. So, and the way this open source maintainers, they don't really spend a lot of time marketing stuff because they believe that if you care about the code, you care about the code. They don't need to tell you why the code runs 5 times faster than the previous version. It's not an Apple keynote, it's like, those are kind of the concept. But unfortunately, I think given the way money is these days, I'm not sure if it's the right thing to do, but I've often seen it to be a little bit more sustainable if you speak corporate language. And I think depending on your experience and your ability to be as relatable as possible, makes it much flexible. Not the best approach, but flexible.
Do you have an example, like even without mentioning names, where you like convinced someone to do a particular investment or?
Yeah. All my companies, I can't mention directly, but all the companies I worked with, I'm always like, so for example, like the last couple companies I've worked with before, our entire marketing strategy changed and they went into open source because they realized that, to sell enterprise software, why CTOs and engineering managers are your typical persona to chase. If developers don't care about your tool, the CTO would not buy it. It's the other way around. Like developers come in and say, hey, I love this tool. I think we should get it. Not the CTO say, oh, you know what? We have this tool. Do you want to use it? Like, it's like very different. So, and it's kind of the Google strategy too, because Google used the GDG program, like the Google Developers Program, as a way to get into the mind of engineers as early as possible. So when they go into like corporate world, becoming a CTO, engineering manager, whatever, it's very natural for them to say, "Oh, use Google," because they were using Google when they were younger. So there's still some element of like letting someone learn how to build something with your tool, because naturally that makes them more relatable. Hence why things like GitHub is gonna be GitHub, regardless of the fact that GitHub is innovating open source. But it was fundamentally designed to for the developers compared to the way GitLab was structured. I always tell my friends the reason why GitHub is different is because one chose to be community and developers focused. Why the ironic is that one is open source and one is not. So, so again, just depending on how you look at it. So I think when they got that message, they were able to change their marketing strategy, and it worked. It worked for them. It worked. It took some time. Then they started having some unrealistic expectations, and then I left.
In this segment, Philipp Ahmann talks about security, safety standards, and open source within the automotive industry.
I want to dive into the automotive space a little bit, because we are talking about company involvement and investment, and I think the automotive space is a little less straightforward when it comes to open source, just because of how strict that industry segment is, and it's not just like requirements, but safety perspective. Cars are on the road, accidents happen no matter what. And then we all know what happens when accidents happen. It can go really, really bad. So the software that goes into those cars, that really has to be like well tested and all those things. And so I would like to understand, and Philip ask you a few questions to dive into this part of the automotive industry, just to help people understand who are not working in this space, like what it takes to put these cars together, not just the mechanical part, because there are tiny little computers everywhere in the cars by now. I don't know what the number is. I think back in the day when I was looking into the automotive segment and really wanted to get involved, I think it was like 80 or 100 ECUs, which is electric control unit. All right, I still remember. So I think it was 80 or 100, and I'm pretty sure that the number just went even further up. Can you share just a little bit, like a high level overview of like what the safety regulations look like when it comes to putting software in a car, and like how the space is standardized? Because I assume that it is standardized to some level.
Yeah. So there's one standard for the safety parts, which is an ISO 26262. This is the number for safety of road vehicles. Interesting enough, there's a second edition now, which includes also motorcycles and trucks. The original one was just for passenger cars, which is an interesting observation on this. And it basically describes the different safety integrity level. The lowest, which is not a safety level, is like a quality management, quality managed level. And this would mean that you have a certain rigor on your processes and your quality already in working without that it's even become safety relevant. And the standard asks that you should show how you have a quality management system in place in your company. So what people often do is to have an ISO 9001 certification, which is like a part of it, but it's the lowest hanging fruit for doing so. Typically then things like CMMI comes in for the maturity level on processes, and what more and more is asked also in automotive SPICE process. And the automotive SPICE process really strongly goes along the V model. You have to do requirements, architectural design, detailed design, which ends up in the implementation. And this is what down the V, then up the V. You have to do always a proper testing, verification, validation. And this continues to harder elements in the safety part. And then there is this automotive safety integrity level, this ASIL. There's also an industry part, which is then the ZIL, like safety integrity level. But the ASIL ranges from A to D. D is the highest level, and A is the lowest level. While I would normally cluster in A and B and C and D. So if you can do an A, you're almost in a good way to do a B. That's why most use cases you will find a B. There's a few where it's A, but most of them is then B if it comes to safety, or then on higher levels it's a D. In a level of B, you could still have what's called a safe state. So you can define how the system would stop operating in a safe manner. I come from the infotainment cluster screen world. So long time it was that people said a safe state could be that you switch off the instrument cluster, like that your meter and so on is no longer displayed, because then you as a user know, oh, there's something wrong in this. And then you're good. Or you have a rear view camera, as long as you detect that when the rear view camera is freezing, you would switch off the rear view camera from the back of the car. You have a safe state. But this does not work for autonomous driving anymore. And this means then you need to be fault tolerant, you need to be fail operational so that you still operate when you fail. This could be very hard for like complex things. And you mentioned the control units, which have been like 100, 120, which currently try to get more centralized because we have so much computation performance and we're cost sensitive. So therefore we try to find our best sweet spot on cost and performance, so we bring things together. And that's where new challenges on mixed criticality come up, because suddenly entertaining infotainment world with your car navigation, radio, and so on should run on the same system, maybe like your map calculation, because both calculate the map, and one is just for the ADAS stack to make your way through the autonomous driving thing, and the other one is just to illustrate where you currently are with your activities. And then you see that there's potential of interference and so on. That's where all these challenging things come up, and where open source has a hard time, especially Linux also, because it was never made for this. And to this rigor, as you say, one person said it's just a rough number, it's like 20% is the source code you're writing, and the remaining 80% is documentation testing. So it's all around this. And what we had for our Linux devices, like from automotive requirements, something is not even safety or quality, it's just experience part, where the things that you need to have the display and everything running up in 2 seconds. So 2 seconds was a typical from ignition to seeing something on the screen. But then there was also kind of quality demands that you need to respond on the CAN bus within 80 milliseconds. You had to have an early gong, which is like putting in a rear gear in 200 milliseconds and 500 milliseconds to see the rear view camera. These are all requirements which you get in and which you need to handle with like software, which cannot be only deeply embedded, where you need to have all this rich function later on. And that's why we spend a lot of time in testing, stability, road tests. You had to drive many, many kilometers. And what we, for example, had is it was a requirement that we do not have a screen flickering or black screen, which means a reset. We're not supposed to have any unintended reset. And I was like, I don't know, I was surprised, so that after 8 years of operation with my car, personal car, I suddenly said, I saw that my infotainment system went off and on, and said, this was a reset. I never experienced it to happen. It never happened again, right? It was just once in 10 years. It was going on and off. But exactly this case should not happen in safety, because this could be the moment where you are on a highway with having a complex traffic situation, and if the system would just decide to restart, actually, I don't know even which operating system was in my navigation device. It was not a Bosch unit, so it's not the one which I built. But this is just like the quality rigor which they are looking for, like no resets, no flickering in screens, strong performance demands. We were testing hundreds and thousands of CDs and mass storage devices with broken MP3s, even things which are not according to the standard, just to see that the system still works. And this is where the entry criteria for automotive comes in before you reach the safety part. So this is definitely a thing there.
I mean, as someone who drives cars, like whenever the dashboard, or not the dashboard, but that display that has the map on or something, it like resets or flickers. Sometimes the connection to my phone somehow doesn't seem to be 100%. Like I haven't caused an accident, but I can see how it could. So even that little thing that is supposedly not a safety critical function can still distract the driver enough to, like, if there was something in those, I don't know, milliseconds or maybe up to 1 or 2 seconds when you were staring at the display that was doing some weird stuff, something ahead of you on the road and you weren't paying attention, that really does matter. So I understand.
This is where the complexity gets in, right? Because you have so much more combined, and where we had traditionally Linux system, it's nowadays also Android, which runs in the central infotainment system, which is like if you do a build of Android, you end up with 100 gigabyte of build information, and then you compress it like to 16, 12, 10 gigabyte, including the map data and so on, like on your device. This is far more than you had, and then you have all the connectivity and the interaction, and then controlling things via app on your phone, and then you say, okay, again, it does not work because it adds so much ecosystem, so much complexity. When we just took mass storage devices, you cannot test all the phones, all the software versions of it. It's super heavy effort. And this is potentially also what I feel is reducing a little bit the trust in things like which coming from the open. They know it's Android, they know it has an open source base, they know it's Linux underneath. They see that these comfort and infotainment and entertaining functions in the car don't work as they would assume that they work. But this is something like also not every supplier is handling in the same way. They may have an acceptance. And I remember that on the local side, the manager of the local side in Hildesheim, who had a car, and whenever he was driving a car where Bosch didn't won later on the RFQ, and it was like, I think it's more than 10 years ago, but he came, I was sitting next to his wife at this time, and she told me that he's complaining all the time that the navigation system stops, does reboots and so on, and said, they haven't selected us. It would never happen with our device. We would be thrown out for these kind of things. How can they make it into production? What are we doing wrong? Why do we have this quality? They can bring this into production, and they've thrown us out. This was really, he was really annoyed, but we saw like 10 years back, like I say, the system which I have, it runs super stable since 10 years in my car, with one reset, of course, yes. It operates still like, I don't feel a lack in performance. It's operating as on the first day. Of course, I don't find the streets anymore because they've built in new roads and it's not updated. It has no over-the-air option, but it's the quality. Nowadays, it's really hard to achieve this with an Android environment, faster demands, more user experience, to really come to this rigor which we had 10 years back. But we see that these projects evolved and made it into other areas. So I know about interior cameras, which run Linux not safely, but safety oriented, and where you can make use of it. And this is actually not a safety function to have a drowsiness detection, because the question is, the driver is drowsy. Anyway, it's more a comfort function that you say, okay, here, please take a rest. There is a risk. There may be a time when it becomes a safety functionality, and people are not accepting that you're taking away your hands. And so then it suddenly becomes from a quality managed convenience functionality into safety critical space. And you need to solve this problem. But here, going with Linux, with the ecosystem, things to exchange, which you can do, that's where it's accepted to go so. And whenever you don't have the safety part, you try to find open source solutions, I would say, and also in the automotive space.
In this segment, Ashan Senevirathne talks about the impact of standardization on building telecom infrastructure, including open source building blocks.
So you didn't have issues with like the features that the telecom operator as Swisscom needs is not something that the community can easily understand what it exactly is, why it is needed. So you did not run into those type of challenges in terms of like trying to get something through.
No, but I think the vendors face this challenge in a way because we do have a bigger topic in on our plates, both vendors and ourselves, to tackle config management, for an example. But it's a telco proprietary interface, and in an ideal world or in an IT-like world, we would like to have the configuration done with non-netconf interfaces, right? So it could be treated like an IT application. But due to the standards with 3GPP and etc., it's not the case. So you need to comply with that and also try to bring this way of life cycling the core into the Kubernetes layer done in a cloud native way. So there, I think everyone's doing a workaround, having this netconf interfaces or this Yang, etc. But I think from that point of view, either it's if it's operator wanting to do it or the vendor trying to tackle it, I think it's a big challenge that solving this puzzle. Because the complexity increases within the 5G core. For the audience, the 5G core is the not the 5G like the radio side, but the network core. We do introduce new network functions every now and then, so the complexity increases, and at the same time, we also have to maintain the 4G core and the 3G. 3G will be phased out, but 4G, 5G, the complexity increases, and we also want to operate the network with less people, right? There's also this cost pressure coming. So how do we increase the productivity aspects and etc.? So, yeah.
So it sounds like that some of the challenges are on the standards side. Are you aware of any conversations or any evolution or changes happening there?
Not really, but we have provided some feedback to one of the standards from our, but what we are involved is ETSI. It stands for European Telecommunication Standards Institute. I mean, there it's taking again. I'm coming back to this Kubernetes aspect. We have this way of operating and life cycling the networks outside to the Kubernetes, out of band Kubernetes, and we want to bring it into in-band Kubernetes. So these things have addressed, and I believe they are looking into it or looking into ways of how to tie these bridges with the CNCF, how to keep up with the phase. Because oftentimes these standard bodies also you need to meet with the consensus, which means it's not moving that fast, etc. So,
and the likelihood that the world moves on to WebAssembly from containers and Kubernetes by the time the standards body engages that's hence the problem of the different speeds of these different organizations.
I mean, I remember back in the day when we were trying to organize some meetings and engagement between the OpenStack community and ETSI, the ETSI NFV standards group, and we did manage to have, I think it was one in-person meeting that we had with a bigger group, because there was a project teams gathering event in Denver, Colorado, and that event is very contributor focused. So OpenStack and other opening for project teams were coming together in person and talk about anything related to the project services that they were working on. And somehow some magic happened in the universe because the ETSI NFV standards group were meeting, I think, the same week and the same city in the same year. So it was fascinating, just like how that magically aligned, because you can imagine that there's no way to influence when a global community meets and when an Etsy standards group meets, like that. It's the same time, same place. So we, on both sides, we kind of fought tooth and nail to make sure that there is a meeting with people from both groups. And I think we had like a 3-hour session, and it was pretty amazing because both sides could have a little more visibility into like who's doing these different efforts, who are the people, and what the contexts are. So having a little bit of understanding on the OpenStack developer side, what goes into standardization, what that group needs to be able to move forward, and vice versa, like how the OpenStack development works and what developers are working with, what kind of requirements, what is their way of working, and just being able to talk to each other. And I think that sped up a little bit the sort of the translation that people need to do between those two groups, because the terms and words that the standards body is using versus developer of an open source project, those are usually not really matching. So we had a lot of challenges in terms of like, why are you saying this? Like, where is that requirement coming from? Like, give me the use case, like give me what you want to achieve. And like on the developer side, and then on the standard side, like I want to have an interface, like I want to have a standard interface. And there was like a bit of a cultural clash. So it was really interesting. And I assume there's still some of that left in this space when it comes to Etsy engaging with now Kubernetes and the CNCF ecosystem, and then WebAssembly comes
Yeah,
down the
exactly.
road.
In this segment, Magnus Buhrgard talks about the relationship between standards and open source within the telecommunications industry.
From my earlier experience working for Ericsson, I did see a little bit of the standardization side, but I wasn't deeply involved with the groups who were doing that kind of work. And I know that there are some standards bodies that are completely closed and member based, and there are some others which are a bit more open. And you have more visibility into how they work, what they do. Can you share a little bit about that segment and how it works and how it affects the work that the telecom vendor companies are doing and are able to do?
Yeah, it varies a lot depending on which part of the network you look at. So some interfaces and protocols are extremely detailed and quite rigid, and have been chosen to work mainly. So yeah, I've been chosen to work mainly with less specific areas when it comes to using and contributing open source. So, and also due to legal implications of patents and so on. But there is a strong tradition to distinguish between standards and implementation. And operators require standards, and they specify them in cooperation with vendors. And but only vendors work with implementation. That is sort of the way that the standard is supposed to work. And when we started to work with this the open carrier base, grade base platform, we used implementation standards as the tagline. But that was not well received by most of the standards community. They hated that. They wanted to have very crisp standards, and they wanted to say that the implementation is totally up to the vendor. But things have changed. I mean, the old rules don't apply anymore. And also since sort of IT technology at large has come into this. So it depends very much on which part. Are you sort of in the radio network interfaces and so on? You're very strictly standards based. and that also affects the way of working within the company. People are sort of the heroes are the system managers who know the standards by heart and know all the details and everything, and they really use that and in those parts of the network, it's mandatory to work with standards. Other parts are not that well standardized, and you can work with that. But also, I mean, there is a contradiction between standards and innovation, of course, that you were alluding to. I mean, you really want to standardize when a service is well understood and well used, and you don't want to innovate or do anything more with it. Otherwise, you will hamper the innovation, perhaps, if you have the wrong interfaces or the wrong standards. And also, if you can't change that interface very easily, then it's difficult to do innovations.
I remember from my OpenStack days that at one point the community was working a little bit with ETSI, the European Telecommunications Standards Institute, and within that the NFV Network Function Virtualization group, and the ETSI NFV was trying to look into how to standardize the cloud interfaces when cloud broke into the telecommunications segment. In your experience, how does open source fit into this standardization world and that aspect of the telecom industry and vendors?
I think they're kind of perpendicular in one sense, because I'm a bit proud of actually having the first ever reference to open source in the standards body. That was in ETSI. In ETSI, that they pointed at an interface in ONA as a standard. But that's the only case I can think of. There is a very big divide between that, and I also think that it's comes from totally different cultures. There is a possibility. Some people like to make sort of the connection between the two and make the best of it, but many don't want to mix them at all. And also there is also this idea, the question of patents and licensing and so on, that makes it sort of difficult to mix open source into standards, because if you're lucky, you get your patents into the standard, and then you can charge other people for that, and that's a big income. Nobody really wants to jeopardize any of that revenue. But also like I said before, the real diehard standards people, they don't want to talk implementation ever. They don't care if you do it in software or what you do. It's, you have an interface that's totally technology agnostic, not in practice, of course, but in the specification.
Well, for me, it seems to be the collision course is too exaggerated of a statement, but as the orchestration of functionality, the interaction of that functionality, when it's based on things like Kubernetes and the way those get orchestrated, the way they interface with each other through the networking that exists within the Kubernetes ecosystem and within containers, and then going out to secondary networking, there's very much a merge, right, of what used to be traditionally telco, autonomous type functionality, originally in hardware, then in software, but now very much integrated into this platform that is the software platform that everybody's using. I mean, talk, what has your experience been in watching that coalescence of the existing functionality of a major platform like Kubernetes with the requirements and then the desire to be so standards based in the telco industry? What has your experience been in seeing that?
Yeah, I've been lucky to be a bit outside of that battle, but because I worked a lot with O&M, operation, administration, and maintenance, I think, or sometimes management, and that's sort of not that sensitive when it comes to, it's not that well standardized, and it's possible to do what you want there. So that's also, you don't have to have a super high availability in that area either, because it's not at the end of the world if you can't sort of access a certain node or a certain equipment at any time. The service will not go down. It's just that you will not be able to read some numbers and so on. But I think that the telecom industry has been, it's not in charge of this development. It has to adjust all the time. And also because the specific technology in telecom is not there anymore. It's sort of basic IT technology that is used to build the networks.
Like you had said, implementation was always owned by the vendors, and so you work out standards, you implement however you want. But now there's so much, again, sitting underneath that is, as you say, not under their control any longer.
And also the latest, I would say latest development, but some development is towards this service-based architecture, which means that the standards don't really work that with detailed interfaces and detailed protocols. There's still that around, but a lot of what 3GPP is doing inside Etsy is a service-based architecture, which means that you specify how the service should look like and how it should work. And then you gain some flexibility in that. On the other hand, you lose clarity, and you cannot guarantee that the equipment that fulfills the standard will work together, which is a kind of a contradiction in terms. But then you have to have a big implementation project when you get equipment from different vendors. And it sort of goes away a bit from the basis of standardization. But that's something that has been driven by operators. Vendors don't really like that, but probably also because they want to make use of new technology, new possibilities, and not being bound to the in-house technology from the vendors.
And with that, that's all, folks. That was our episode for today. We want to hear from you. Please leave comments under the episodes that you watched. Share your feedback and share your experiences to continue the conversation. And let us know what topics you would like to hear next. Stay tuned because the next episode is just around the corner.